Welcome to today's video. This video is about why do clouds float? Clouds may look heavy, thick, and full of water, yet they drift effortlessly across the sky as if they weigh nothing at all. How does something made of water float above our heads? The answer lies in a delicate interplay of invisible forces. Air pressure and gravity. While gravity constantly pulls the water droplets down, air pressure below provides an upward buoyant force that keeps them suspended rather than crashing to the ground. Imagine air pressure working in a way similar to how water supports a floating ball. Just as the water pushes upward against the ball, the air below the cloud exerts an upward force on the tiny droplets, allowing the entire cloud formation to float gently above us. This continuous balance will enable clouds to float above us gracefully. Let's dive into this curiosity with a simple idea. Clouds are far lighter than you think, but not for the reason most people believe. The secret lies in tiny droplets, rising warm air, and a delicate balance that turns the sky into nature's biggest floating machine. To understand why clouds float, imagine holding a sponge full of water. That sponge is heavy. Now imagine that same water spread out into millions of microscopic droplets, each lighter than a grain of dust. When water in the air condenses into droplets, they are incredibly tiny, so tiny that a single cloud can contain billions of them and still stay afloat. Clouds are made of water, but not in the heavy, liquid form we're familiar with. Instead, they're made of tiny droplets and ice crystals suspended in air. Ice crystals typically form in the colder, higher clouds, while the lower clouds are mainly composed of droplets. This distinction helps explain how different conditions give rise to other cloud types and behaviors. Here's the key idea. Clouds float because the air beneath them is warmer and lighter, which pushes the cloud upward, much as warm air lifts a hotter balloon. As warm air ascends through the atmosphere, it carries with it countless tiny water droplets. This balance of forces, with warm air pushing upwards, with more force than gravity pulling down, keeps the cloud aloft. Over time, these tiny droplets can merge with other droplets or collect more water vapor, gradually growing larger. When these droplets become large enough, or if the warm air stops rising, this balance tips, and the cloud can no longer remain suspended, leading to the formation of rain. But that's only part of the story. To really understand why clouds float, picture a feather drifting in slow motion. It doesn't fall quickly because its surface area spreads out its weight. Cloud droplets behave similarly. Each droplet is so small and so light that gravity pulls on it very weakly, and because the air molecules around them are constantly moving and bouncing, they keep the droplets suspended, almost like they're floating in a slow-motion dance. Now, imagine you're inside a cloud. You'd be surrounded by mist, a cool, floating fog. That's precisely what clouds are. Fog that forms high in the sky. The only difference is temperature, altitude, and how much warm air rises from the ground. Without the upward push of warm air, clouds wouldn't hover. They'd settle and fade. Let's break it down even more simply. 1. Clouds form when warm air rises. Warm air holds more water vapor. When it rises and cools, that vapor turns into droplets, forming a cloud. Cloud droplets are about 1/100th the width of a human hair. They're so small that they fall incredibly slowly, sometimes only a few centimeters per second. These microscopic droplets are individually invisible to the naked eye, but when they come together in large numbers, they form the visible clouds we see floating in the sky. 2. Rising air keeps the droplets suspended. The upward motion of warm air is stronger than the downward pull of gravity on these tiny droplets. 3. Clouds float until conditions change. If droplets grow larger or heavier like in storm clouds, they eventually fall as rain. This balance between rising warm air, cooling temperatures, and tiny droplets is what allows clouds to float gently across the sky. It's not magic, it's physics and thermodynamics working together. Now think about the different types of clouds. Wispy cirrus clouds float high because the air is cold and dry. Puffy cumulus clouds can tower like mountains because strong warm air currents lift them. Stratus cloud, on the other hand, form in large horizontal layers and often cover the sky like a gray blanket. These clouds are closer to the ground and are generally caused by the cooling of a large body of air as it moves upward. Dark storm clouds appear heavy because the droplets inside them are growing, becoming too heavy to stay aloft. A combination of temperature, humidity, and air movement influences the type of cloud formed. Cooler temperatures and higher altitudes lead to the formation of cirrus clouds, while warm ground-level air rising rapidly forms towering cumulus clouds. Higher humidity levels combined with cooling air currents produce dense stratus clouds. That's the moment clouds stop floating and start raining. Here's a relatable analogy. Imagine blowing soap bubbles. They float because the air inside them is lighter than the air around them. They drift until gravity finally overcomes their delicate balance. Clouds are like giant, natural bubbles, except instead of soap, they're made of water vapor and tiny droplets. The next time you look up at the sky and see a cloud glowing in the sunlight, remember that you're watching millions of water droplets floating on invisible currents of warm air. Every cloud is a balancing act, a delicate dance between rising heat and falling droplets, and the moment that balance shifts, rain begins. Let this thought stay with you. Clouds aren't just floating decorations in the sky, they're living maps of the air above us. They reveal where the atmosphere is warm, cool, rising, or falling. When you understand clouds, you know the story of the sky. If you enjoyed this video and want to learn more fascinating science facts, hit like and subscribe for the full playlist. The link is provided in the description. Thanks for being curious with me today. I truly appreciate your time and interest. Stay tuned for more exciting content.